Okay, here's another example of graphing a rational function. First thing I would do is just identify the in-between points. Then we're going to look at the end behavior. Then we're going to sketch the graph. We're really just going to type it in advanced graphic, but it's good to understand what's going on with your x-intercept, your y-intercept, your vertical asymptote, and your horizontal asymptote. Remember, an asymptote is a line that a graph approaches as you move away from the origin. And I'll kind of explain that as I go along. But it's simply a line that a graph will approach as you move away from the origin. It'll get closer and closer to that particular line, but it won't touch. Most of the time, this is basically where the particular function is undefined, but not all the time the case, so it just kind of depends on the function. First thing I want to do is let's identify the x-intercepts. X-intercept, take the numerator, solve that for 0. Well, I'm going to go 2x plus 7 equals 0. Let's do that in our head. Subtract 7. Your x-intercept is x equals negative 7 over 2. Well, this is referring to when this graph will cross the x-axis. Where is negative 7 over 2? Estimate 2 goes into 7, what, 3 times? That's about negative 3.5. 1, 2, 3, about here. Let me change up my color. Okay, so negative 3.5, 1, 2, 3.5, about here in estimate. Alright, y-intercept. That's where your graph will cross the y-axis. Well, here you just place a 0 in for x. Put a 0 here, or 2 times 0 is 0. 0 here, 0 squared, that's going to be 0. So your y-intercept is going to be negative 7 over 9. That's where it crosses the y-axis. Well, here's your y-axis. Go down. Where is negative 7/9? Well, it's less than negative 1. So I'm just going to estimate. Not exact. Okay, vertical asymptote. That's, remember, an asymptote is just a line that a graph approaches as you move away from the origin. So my vertical asymptote, I'm going to take my denominator, set it equal to 0. Well, x squared minus 9, you just factor that. X plus 3x minus 3, set that equal to 0. So your vertical asymptote will be x equals 3 and negative 3. So I go to 3 and negative 3, put a dotted line. That's simply a place that this graph, it'll get closer as it moves away from the origin. It'll get closer and closer to this line, will never touch. So we have some different things going on with this particular function. That's why I grabbed this function, because I like the way it looks. Horizontal asymptote. For this one, remember the rules. If your numerator exponent is smaller than the denominator, your horizontal asymptote is 0. If it's the same, then you take the leading coefficients, divide those, then it would be that particular value as your horizontal asymptote. If the numerator is larger, then it doesn't have a horizontal asymptote. It could possibly have what's called a slant asymptote, but we won't talk about that or discuss that in this particular session. So here we have a horizontal asymptote of y equals 0. So that means this line, and the line I'm talking about is the actual axis. Well, what's going on here? We have an intercept here. The graph is going to cross here, but this is an asymptote. What's going on? Remember, let's look over here. This is your y-intercept here. What we could do now, if we were doing this by hand, we could just plot some points to kind of see what the picture is going to look like, or just go to advanced graphic or some type of graphing tool and see what we got going on. Here's your graph. Kind of makes sense now? Goes here, gets closer and closer to negative 3. Here, closer and closer to negative 3. Crosses the axis here. Here. This particular line here, this is the one that's going to get closer and closer to 0 for your horizontal asymptote. So this is what the graph of your function looks like. It's good to look at the middle behavior just so you can get a full picture of what you're looking for.